Welcome. In this video, we are going to talk about the idea of formal charge. And these are some notes that are on page 13. So we're kind of following up with where we're at with page 13 in class. And there's some practice problems on page 14 that are combining ideas of resonance and formal charge. So the formal charge is something we can use to determine which Lewis structure is the most likely out of several possibilities. So where this is helpful is if you have a few different structures that all follow the octet rule, and that they all have the right number of electrons. Like for example, down here with, CO2, we know that in CO2 we will have 16 electrons in it. Okay. So notice both these structures have 2, 4, 6, 8, 10, 12, 14, 16 electrons in them. But in one possibility, we show, and everyone's got an octet around them, right? So carbon, both oxygens, they all have an octet. But in one possibility, we have the carbon forming two double bonds. Another possibility, we have a single bond and a triple bond. So the formal charge is something we can use to help us figure out which structure is more likely of these two. Turns out that this structure of CO2 is the more likely structure, and we will be able to figure out why. So first we want to know how to determine formal charge. So you determine formal charge when you are looking at a Lewis dot structure that's already drawn, such as this one right here. And what you do is you count up the number of valence electrons that an atom of that type would typically have on its own. And then you subtract from that the number of non-bonded electrons that are around that atom in the structure and half the number of bonding electrons. So there's going to be a little subtraction happening here. So those non-bonded and half the bonding electrons, those are referred to as the electrons assigned to the atom in the structure. So that might still seem very confusing. So here's maybe a simpler way of thinking about it. To find the formal charge on an atom in a Lewis dot structure, what you do is you look at the column number it's in of the individual atom. That tells you the valence electrons. And you subtract from that the number of dots and the number of, lines. So the number of bonds would be like the number of lines around that atom in the Lewis dot structure that you just drew. So this might be a little simpler way of looking at it. So let's look at some examples here. And actually, before we do that, what's the purpose of finding the Lewis structure? Well, this helps us figure out which structure is the best and what will actually kind of occur in nature. And the best Lewis structure is the one with the fewest charges. So if you can have formal charges of 0, that's the best. That's best case scenario. And if you can't have all the charges be 0, then the next thing you want to do is you want to put the negative charge, the most negative charge, on the most electronegative atom. So down here, here's 3 different possibilities for drawing out a Lewis dot structures of the CNO minus ion. And when you find the formal charges on these various possibilities, we'll notice that this structure here is the best. The reason why is it's got the most possibilities at 0. Like this one's not great because it's got a 2 and a 1 and only 1 0. So having 2 atoms at 0 is better than this structure. And if you compare option 2 and option 3, you have to have a -1 formal charge in here somewhere, and you can either place that on the nitrogen or on the oxygen. And if you look at your periodic trends, you will notice that your oxygen is the most electronegative element of those 3. So if there has to be a negative charge somewhere, it should go on the oxygen. So here's some examples with another example with formal charge. So CS2, we've got this possibility over here on the left gives us all formal charges of 0. This possibility on the right, not all the formal charges are 0. So it turns out this structure is the best structure, where your C is forming 2 double bonds. So let's go through some examples of actually finding a formal charge. So I'm going to use this example from our previous practice problems on page 12. So this is problem number 5. So NH2OH. If you count up the number of electrons, you've got 14 electrons. And there's 2 main ways in which you could draw this structure. Actually, I guess there's even more possibilities. Let's draw out another one as well. We could have put O in the middle, too, maybe. So there's a couple different ways in which we could have drawn this structure that all would satisfy the octet rule. Okay, so all three of these, octet rule is met. Everyone's got 8 electrons. Who wants it? And then we also have the correct number of electrons. So the question is, which structure is actually, the best structure and why? And we can use formal charges to help us figure that out. So remember, the rule for formal charges is you take the number of valence electrons, which has to do with the column the atom is in, and you subtract from it the number of dots and the number of bonds that the atom is forming in that structure. So let's go down here and take a look. So over here on the left, if you take a look at your hydrogens are in column number 1. Hydrogen has 1 valence electron. If you look at the number of dots on my hydrogen, it's got 0 dots on it, and it's forming 1 bond. So my hydrogen's has a formal charge of 0. And notice how all the hydrogens are the same. So all my hydrogens in all these structures have a formal charge of 0. So that's good. My hydrogens are looking good so far. Okay. Now let's take a look at my oxygens. Let's color code these. Okay. My oxygen over here, let's look at in this structure. So I take the number of valence electrons, which would be 6, is how my oxygen normally has. I subtract from it how many dots are around my oxygen. That's none. And then it's got 4 bonds on it. So my oxygen over here has a formal charge of +2. So 6 minus 0 minus 4 is +2. Nitrogen typically has, if I look at what column it's in column 5. It's got 5 valence electrons. It's got 1, 2, 3, 4, 5, 6 dots around it, and it's forming 1 bond. So again, column number minus the number of dots minus the number of bonds, that gives you the formal charge. So 5 minus 7, this has a formal charge of -2. Now let's compare it to this one. Hydrogens are all 0. We already figured that out. Let's look at our nitrogen here. So my nitrogen here, again, I look at the column nitrogen's in on the periodic table. It's column 5. I subtract the number of dots around it. There's no unpaired electrons. There's no dots, but there's 4 bonds. So it's got a formal charge of +1. My oxygen right here, oxygen's in column 6. So it's got 6 valence electrons typically. In this structure, it has 1, 2, 3, 4, 5, 6 dots around it, and it's forming 1 bond. So it's got a formal charge of -1. So far this possibility seems better. Let's label these A, B, C. So far B seems better than A. Do you notice that? Because see how the formal charges are less? They're +1 -2 versus +2 -2. So the lower the charges, the better. We want them as close to 0 as possible. Now let's take a look at our third possibility. So our hydrogens are still 0. We already calculated that. They're all the same here. Our nitrogen typically is in column 5, so it's got 5 valence electrons typically. In this structure, it has 2 dots on it and 3 lines. So nitrogen has a formal charge of 0. That's looking good. Okay, now let's look at our oxygen. Oxygen typically has 6 valence electrons. It's in column 6. It's got 4 dots on it in this picture and 2 bonds, so it's got a formal charge of 0. So hooray, this is actually the best structure. Everyone has a formal charge of 0. That is the best case scenario. So this is actually the structure that this molecule will take in nature, is this one over here. You'll notice excuse me, you'll notice a connection. You might even notice it from these examples right here. That notice in the one that had the best formal charge, notice how nitrogen's forming 3 bonds and oxygen's forming 2 bonds. And you might remember this pattern from general chemistry, this honk 1, 2, 3, 4. So typically, hydrogen will form 1 bond, oxygen will form 2, nitrogen will form 3, carbon will form 4. This doesn't always happen, but it does happen a lot, and that's why it's a meaningful pattern that we point out in regular chemistry. And it turns out that when your structure follows the honk 1, 2, 3, 4 pattern, you will notice that the formal charges on the atoms will be 0. So like in all these examples, all of them have formal charges of 0. So just FYI, that is why it is a pattern that we notice, is because when they follow this pattern, they have a formal charge of 0. Cool. Okay, so here's a practice problem. So what you do is to pause the video and then use the steps that we talked about, use that formula to find the formal charges on all 3 atoms in all 3 structures. So you're going to calculate 9 formal charges, write them down. Remember, this is on page 13, so you can do this along your notes. So pause the video right now and do that, and then you can check back in and check your work in a moment. All right, so I'm going to assume that you've paused the video and you've tried these already. Now we're going to stop and go over it. So if you look at the example on the left, it turns out this one ends up with the best formal charges. Okay, and again, the way we find the formal charges is you look at the column it's in. So sulfur is in column 6. It's got 6 valence electrons. It's got 4 dots on it in the structure, and it's got 2 lines sticking out of it. So 6 minus 4 minus 2, it's got a formal charge of 0. Your carbon, it's in column 4, so it's got 4 valence. It's got no dots on it in the structure, but it's got 4 lines. So 4 minus 0 minus 4, it's got a formal charge of 0. Nitrogen has 5 electrons typically. It's in column 5. It's got 4 dots in this structure and 2 lines, so it's got a formal charge of -1. So you kind of go through and do this pattern on all 3 possibilities. And what you will notice is that we can eliminate this third one as a possibility, because notice how this one has charges of 1, 0, and -2, versus these 2 examples have 2 charges being 0. So ideally you want to get as many atoms at 0 as possible. So this one's definitely not the best choice. These 2 seem better. And the way that I tell the difference between this first option or the second option is looks like we have to have a -1 charge assigned to someone. And so the rule is that you want to have the negative charge on the most electronegative atom. So if you look at your periodic trends, sulfur, carbon, nitrogen, you'll find nitrogen is the most electronegative element of those 3. So the best structure is the one that gives the -1 charge, -1 formal charge to the nitrogen atom. So that's this possibility right here. All right, so that's a little bit about formal charge. Let me know, reach out if you have questions.